Hello, Finxters. My name is Nick Morris, and welcome to this video about the Python try except block. I'm going to be going through some code examples illustrating the Python try except block. Most of these examples can be found in my article that I wrote for this for Finxter. You can see here on the left, Python try except an illustrated guide. There's a few illustrations in there to help you sort of understand the concepts. And then over here on the right of my screen, I have a Google Colab notebook with some code examples to take you through and show you how things work. So let's start off with, I'll open up here what I've called overview problem. So this actually brings together everything that I want to go through, all the basics. And the idea here is that I want you, hopefully by the time I'm finished, you'll be able to look at this and you'll be able to figure out what the output is going to be when we run this code. So I'll just briefly explain what's going on at the top here. Basically, we've got this list, which has 1, 2, 3, 4, 5, 6 elements in it, LST, list. And then using the random package, I am going to be drawing out an index, randomly selecting an index between 0 and 7 inclusive, and selecting, using this line here, selecting an item from the list using the random number. So basically randomly selecting an item from the list, or randomly selecting an index and then applying that index to the list. You'll see why I put it that way a little bit later. And then the code will do something different based on the different items pulled from the list or the different indexes used. And hopefully once I've explained everything, you'll be able to look at the code and then imagine what the output's going to be for each of the different six different inputs here. But before we get to that, I'll come back to that at the end. And let's go through some more simple examples first. So first of all, let's just give a quick sort of definition or overview of what the try except block is in Python. So Python's try and except keywords are used to catch an exception and handle it, preventing it from terminating your program as it normally would. This can be useful in situations where you know there's the potential for an exception to occur, and you want your program to be able to continue even if that happens. Now, let me show you here with this block here. So in this block, we don't have the try except in there. And what we've got is just kind of simulating the idea of you've got an inputted value, and maybe there's a situation where you want the user to input a number, but of course they've gone ahead and they've written that number as a word when you actually wanted them to put in an integer number. So let's see what happens when we try to convert that input into an integer. So that's what the int method here does, but because it's a string, a word, and not an actual number. Let's see what happens. Now, if this was correct and there was no error going to happen, then what we'd expect is the next part of the program next to run as well. So let's see what happens. So we'll run this. Not looking good, and yes, it's thrown an error here, an exception, if you like, called the value error exception. And our part of the program print I'm next, it did not occur because this exception terminated the program and stopped it from running. So the idea of the try except is that we can allow for some sort of exception to occur, and we can handle that, and we'll still be able to sort of know that there was an exception because we'll be able to print something to the screen, or we'll be able to log that event. But then the program can also continue, and we won't have this termination of the program like what has happened here. So let's just say that again. So I've got minimal example. Basically the same thing as what I just had, but now I've wrapped it in the try except terminology. And I'll just bring up the basic syntax diagram here on the left to show you what's going on. So let's just correlate the two so you can see. So we've got the try and accept keywords, try and accept here. We've got the code to try, which is in this case is the same as what we had above. Input number equals int of the input number above. And we've got what to do if there's an exception. And in this case, if there's an exception, we're going to print error and then E, which is the information of what the error is. This part here, index error, that's what this is, the exception name. So specifically trying to capture a name here. And a named error. And then of course with the next part of the program. So this part in here is known as the try clause, this part is the accept clause, and the whole thing is known as the try statement. So now, interesting to note here, so I've picked index error. Let's see if that is the correct error. So the error that you identify here has to match the error, so the exception that you identify here. It doesn't, the reason I'm being specific there is that an exception isn't necessarily an error. You could think of it as an exceptional circumstance. So you can create your own exceptions, and they can catch things that are just exceptional. They're not errors. Most of the built-in exceptions that we're going to be dealing with are errors of a type, but it's not necessarily, they're not really entirely synonymous. But of course, if it's got error in the name, you could think of it as an error. Basically, so in order for this to work, you need to name the name that you have has to match the exception that's going to occur. So let's see if index error works in this case. So let's run that. And really here, I wanted to demonstrate that, okay, so what we basically got the same thing as what we had above, where we had a value error get thrown and the program stops. So our try except didn't work in this case because the error of the exception that's been named here is not the one that was actually produced by this try clause. So what was produced is a value error. So let's just change this to a value error, and we'll try again and see what we get this time. So this time we got something that looks much better. So now we're getting the output here, error. So that is what's something here, and then error E. So this is the information, invalid literal for int with the base 10, and then our input 5 there, input number. So that's much more intelligent, and we can see our program has not terminated with the error because the I'm next part has also printed out here in our output. So this is how the try except block is meant to work. Now I'll come to that in a second. So I said here that you have to name the right error. So if you want it to catch a specific error, then you have to name a specific error. You don't actually have to put a name in here, and I'll cover that in a second next. But if you have a name here and it doesn't match the exception that was raised, then it won't work, and we'll get that error, that terminating error we saw in a second ago. So let's go down to exception names. So in that last example there, I did name the error, the value error, and before it was index error, and that was wrong, of course. It didn't match the one that was raised. And in this case, I've actually just said exception. So I haven't actually even said a name of an error. Now, that's covered in the article. We come down to exception names and hierarchies. So if you actually go to the Python documentation, you'll be able to see a whole list of built-in exceptions, exception hierarchy it's called. This is just the top half of it. But you can see basically there's a hierarchy here. So the topmost exception is called base exception, and all of the built-in exceptions are sort of in a child relationship to that. So that if you use base exception, that will capture all of them. Let's show you how that works. So if I use base exception here and run that, we'll get printed out ABC from our try clause here, and then we've got an error because it's an index error, and I've just printed error here. I mean, I can change that to capture the information. So as E, and then I'll just do this E. Okay, so now we get list index out of range. That's the error that's occurring here. So we've got base exception. So all of the possible built-in exceptions are all related to base exception. They're all captured by base exception. If I use exception on its own, that's this one here. Basically, it'll still work in this case because it's an index error and index is below exception, but it wouldn't work for these three above it. And you can find further down, for example, in the last example, there, when we used a very specific exception name, we used index error, and then it didn't match because it was a value error. So I'll just show you using an exception here. So that works. And you can also use no you can use no value exception name at all if you want. So we just say except. And that works as well, but we just see error, we don't see the information. And so the PEP 8 recommendation here, I'll put it here, is to always mention a specific exception name whenever possible instead of the bare except clause. So bare except clause is what we've got here. So that's sort of not really a best practice. So you want to always try and mention a specific exception name if you can. And that sort of goes along with the idea that when you're using try except, you want to be doing it because you're anticipating particular types of errors and you've got something specific you want to do with that error when it occurs. It's not really about capturing sort of any possible error that could occur. But although you can do that as well, and there perhaps maybe are legitimate reasons to do that, but in most cases, the best practice is you want to capture a specific error name. And you will see, I'll come back to that in our main big example where you can see how different ways we can capture different errors by their names, and we can also group them together to make it more easy to do that. Okay, now we've covered try and accept a few different times, a few different examples. I want to come back to some other keywords that we can use, which are else and finally. So in this example here, we've got try and accept again. But then we've also got two new keywords, else and an else clause, and finally and a finally clause. So what do those do? Let's find the relevant section here in our article. Okay, so the else clause will execute if no exception is raised within the try clause. And then the finally clause will execute regardless of whether there's an exception raised or not. So I've also got a diagram here that illustrates that. So this diagram just sort of shows the overall flow of the try except clause. So execution of the try clause up at the top here in the orange box. And then Python is going to determine whether there's an exception within the try clause. If there is, goes over here. We see if it matches an accept clause. So that's matching the name. So that could either be a specific name like we raised before with and we tried index error in that earlier example and it didn't match. So that's an example of it not matching. So that's a no, and we had an execution of the execution of the program stops. Or when we change that index error to a value error, as you can see here, that's where it did match, and we've got a yes here, and then you execute the relevant except clause. So in that case, we did get the match, and that's when we got the error being printed out, and the next part of the program running as well. So that's this except clause running, and then we go along here to the arrow, and we connect back up to this line, and then we get to execute the finally clause after the except clause has run, if there's been an exception. Now, if there was no exception, so up here, there's a no, then we can execute the else clause and then the finally clause, assuming there are ones. So let's see what's going to happen in this example. So in this code example, we've got a list here of 4 numbers, and we've got a for loop here. It's just going to go through each number in turn, and it's going to run those numbers through this try except else finally block. And then once we've done that full loop, we'll try to do the arm next down the bottom here. Sorry, once we've done the full loop, it'll do the arm next down the bottom. And what's actually going on here in the try, so we're doing it similar to what we had before. We're going to try and turn the number from the list into an integer, and then we're creating a new value, dividing 1 divided by that integer, and that's our new value. And then if it's successful, so if there's no exception, we're going to print that value. So that's the else clause here. So that happens if there's no exception. And then regardless of whether there's an exception or not, we'll run the finally clause here. So another one bites the dust is what happens then. So let's run through and see what we get. Okay, here's our output. So our first number was the number 3. So that gets run in. It's already an integer, so that's 3. So we get the new value was 1 divided by 3. So that's going to be 0.333. So that's coming in here. So it was successful, no exception. Go down here and we execute the else statement if there is one. Yes, there is. So the else is print new value and then the new value, and that's what we get here. What happens next? The finally statement gets run. So that's where we have our finally here, and we print another one bites the dust. That's what happened here. The next number to come in was a 0.4. Now, when we convert that to an integer, it gets rounded down, so it becomes 0. So then we get 1 divided by 0, and you may or may not know that you can't divide a number by 0. That's a sort of mathematical error. So, and it's actually known as, the exception is known as the 0 division error. And because we've named that here in our accept clause here, it's going to run this block. So coming back to our flow diagram here, so we got exception. Is there an exception? Yes, we got a 0 division error. Does it match one of the accept clauses? Yes, it matches this one here, and therefore the accept clause gets run. That's this one here, print error, and then the information of the error. That's what we get here, error division by 0. Back to our flow chart, comes back over here. We're not running the else statement because there was an exception, but we do still run the finally statement here, the finally clause. So the finally clause, other bites the dust, gets run. And same thing again, we got 8, similar to the first number, that was successful. And that we print out the new value, and another one bites the dust again. And then the fourth value here is a 0. So we get, again, the divide by 0 error. So we get the exception, matches the exception, execute the accept clause, which is to print the error. That's what we get here, error division by 0. Then we go back, get our finally, another one bites the dust. And then finally, at the end of the program, end of the block, we get I'm next being printed. Okay, so that now covers off all the various elements of the try except block. So try except, else, and finally. Now let's come back up to our overview problem. There's a few other things I wanted to point out in here that I've sort of briefly mentioned so far, but this sort of brings them all together. So as you can see, you can actually have several different except blocks. You can only have one try block within the same try statement, but you can actually have nested statements, but we're not going to go into that here. But we have one try block or try clause, but then we can have several except clauses, and we can use that to handle different types of errors. And here we're handling or identifying an index error with this except clause, and the next one we're identifying and calling out this type error. And then of course in this third one we've got another option here where we can actually use brackets to group together 2 different error types, and you could add as many in here as you wanted to, and then we can handle them together. So let's say you've got one particular action you want to do for an index error, another particular action for a type error, and then for a value error or a 0 division error, you've got one action that's going to apply to both. So you can just group those together to make things easier. And then we've got our else clause, which we're just going through before here, and our finally clause, and our next part of program. So I'm hoping now that I've been through all the various parts, you'll be able to tell me what to expect, or you'll be able to say, what you're going to expect from the output of this code if we run it several times, and we're running it through several different values from this list, or should I say several different indices of the list. So let me just run it several times, and hopefully you'll be correct in your guesses. So there's one. List item was the word 6, this one here, and our output was my value or 0 division error, and then some error details. Then this block is finally over, and then I'm next. So let's just trace back what would have happened here with our diagram here, our flow diagram. So the try clause is executed, and then it looks for an exception. So the word 6 comes in here, gets printed out, and then our int method here tries to turn that into an integer, and of course we can't turn that word into an integer, so that's where the error it gets thrown, and it's a value error. So that's gets identified by the value error here, and that's when we get this except clause printed out, my value or 0 division error. Then that's here, that gets executed. Then we go to the finally clause, execute finally statement here, and print this block is finally over. Gets there, and then we get into the program. I'm next. Let's try again. Probably hopefully get a different one this time. So we got list item 0. That's the last item in the list. And that gets put in here. And it gets put in, and it's going to raise another error. And again, we get this third except clause here being returned, and my value or 0 division error, division by 0. Then we go back to the finally block again, and I'm next. So same as before. Okay, run it again. This time we've got the 4, and this one goes through successfully because a 4 is already an integer, so that's fine. And 1 divided by 4, that's fine. So no problems there. So that none of our except clauses were run, and therefore it's a no for exception, and therefore our else clause, else statement gets executed. And our else statement again is print no exceptions. We got that down here, and then our finally gets executed. This block is finally over, and then our next at the bottom. Let's try one more, shall we? Oh, we had that one. Okay, here we go. This is an interesting one because we didn't get the list item printed. Why is that? Because the error here is an index error. So we did execute the try clause. An exception was raised. Where was it raised though? So it was actually raised before we even got to the this print list item. That's why we didn't see that in the output. It means that our random int here picked an integer of either 6 or 7. So there's only 0, 1, 2, 3, 4, 5. So the fifth element, sorry, the sixth element in the list is index 5. So that means index 6 or 7 is going to be outside of the list, and therefore we're going to get the index error. So that means the error is already coming in this very first line of the try clause, and therefore we don't get to just printing the list item. That's why we didn't see it down here. But yet the exception was raised here. Did it match one of the except clauses? Yes, it did. It matches this one, the index error. That's why we got my index error being printed out and the error information. So that was the except clause being run. And then down here, and again, of course, the finally statement, the finally clause gets run. This block is finally over, and our next part of the program. I'm next. Okay, I'm going to leave it there. hopefully you would know what the other ones we didn't get through would have done as well. That's basically all from me. Just a quick note to finish off. I wanted to say, if you enjoy this type of problem where you get to sort of look at a code snippet and try and guess what the output would be, and then you can check your guess to make sure it's right. That's actually the primary mechanism in the Finxter app for learning Python programming, and it's pretty good fun, and you're learning all the time. So I suggest you check it out if you enjoyed this sort of way of learning. So check that out, and thanks for watching, and I will see you in the next video. Thank you.